Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and thermodynamics is my topic. And in this lecture series, this is lecture number 8. In this lecture, I will explain you two different processes. One is adiabatic process. Adiabatic process, normally a process. So adiabatic process is defined as that one in which no heat enters and no heat leaves the system during each step of a change in a state of system. That means you cannot remove energy or you cannot add energy in a system. That is called adiabatic process, and therefore heat changes will be zero. So dq is equal to 0. This is possible only in isolated system, where exchange of energy and matter is not possible. That is isolated system, and the example is thermos. Okay, so let us take one thermos. In this thermos, a reaction is going on. Gases are filled in this chamber. Okay, and as it is an isolated system, some reaction will occur. There are two types of reactions, either exothermic or endothermic reaction. So if you take, for example, exothermic reaction, which occur inside this thermos. So in exothermic reaction, energy evolved. That means energy released. Okay, and because it is isolated system, it is in isolated, energy evolved in isolated system. Therefore, energy or heat remain in the system. This heat, this extra heat, will increase temperature of the system. So change in temperature is possible. So here you find change in temperature. But exchange of energy not possible. Not possible in exothermic reaction. Similarly, in endothermic reaction, heat of the system is utilized. and therefore energy of the system decreases, which will reduce temperature also. Thus, in adiabatic process, the temperature of a system changes, but energy exchange is not allowed. So heat changes will be zero. Okay. Example is the sudden bursting of a cycle tube during puncture. So this is an example of adiabatic process where the sudden bursting of cycle tube takes place, and you must have experienced this either in maybe cycle or scooter or in different vehicles. Okay, so this is all about adiabatic process. Now we will see another process, and that is isobaric process. Again, name itself reveal that isobaric means it is related to pressure. So isobaric process is that process in which the pressure of the system remains constant during each step of the change. In a state of a system. That means dP is equal to 0. There is no change in pressure. Okay, dP is equal to 0. That is the condition of isobaric process. Now we will see two different examples. Suppose the first one, let us take this one. This is a cylinder in which two gases are filled, 2 moles of hydrogen and 1 mole of oxygen. And here is a piston. To maintain the pressure, external pressure, we will put weight on this. Okay, so we'll put extra weight on this. So this is the initial condition or initial state, and these indicate pressure. So here we can say that P external is constant. Okay, now the reaction occur inside this. At present the number of moles are 2 plus 1, 3. 2 moles of hydrogen, 1 mole of oxygen, number of moles are 3. Okay. Now, when the reaction takes place, and the final product is H2O, but 2 moles of H2O. So obviously, number of moles are 2 only. So from 3 to 2, as number of moles decrease, volume decreases. So without changing pressure, this piston moved downward, and now even if we have the same amount of pressure, see, pressure remain constant, we are not changing the pressure. So P external is the same constant which was in initial state. This is the final state. But because number of moles of product decreased, here volume decreases. So if it is volume V1 and if it is volume V2, then we can say that V1 is greater than V2. Why? Because number of moles are decreases, because N1 is greater than N2. Okay, here we call it N1 and this is N2. Then here we can say that final product is having less number of moles and therefore volume changes. So this is isobaric process. In isobaric process, volume changes at the cost of constant pressure. Okay, similarly, if you take another example, and here we will fill N2O4 gas, number of mole is 1, volume is V1, pressure remain constant, so P with this help of weight is constant. This is external pressure which is constant, and during the reaction N2O4 produce NO2, but in that case number of moles are more, so piston move upward and final product is NO2 gas. So here N2 is equal to 2. So if final mole increases, volume increases, keeping pressure constant. Okay, so this is an example of again isobaric process. Why? Because external pressure is constant. But if V1 is less than V2, N2 is N2 is greater than N1. Okay, so this way volume increases. So volume increases if number of mole increases at the end of the reaction. So this is an example of isobaric process. That's it in this lecture. Thank you so much.